Statistical interaction describes a relationship between two variables that is dependent upon or moderated by a third variable.
For instance, do you prefer ketchup or soy sauce? Obviously, your answer depends on what food you're eating. If you're eating sushi, you probably prefer soy sauce. And if you're having a burger and fries, you're probably going to want ketchup.
In this case, the third variable is referred to as the moderating variable, or simply the moderator. The effect of a moderating variable is often characterized statistically as an interaction, that is, a third variable that affects the direction and/or strength of the relation between your explanatory, or X variable, and your response, or Y variable. What if the population we're studying has different subgroups? Could it be that, like the soy sauce ketchup example, different subgroups could have a moderating effect on our association of interest?
To explore this idea, we're going to use a hypothetical study and some made-up data. In our imaginary study, we're looking at two diets and their effects on weight loss. Diet A is a low-carbohydrate plan. Diet B is a low-fat plan. Our hypothetical study also recorded data on which exercise program participants chose, cardiovascular exercise or weight training.
Our variables of interest are diet and weight loss. We've added this third variable, exercise plan, to help us understand moderation or statistical interaction. So what's the association between diet plan A and B, our explanatory variable, and weight loss, our quantitative response variable? This table shows our hypothetical data showing diet, weight loss, and exercise plan. Since we have a categorical explanatory variable, diet plan A or B, and a quantitative response variable, that is, weight loss, we will of course need to use analysis of variance to evaluate the association.